Okay, so I don't know if you guys saw the assignment, but your exam is coming up on Wednesday, and that's on chapter 3 material, and you're going to be taking the test on my math lab. And so the test will be open all day on Wednesday. So from 12:01 a.m. on Wednesday till 11:59 p.m. And so you want to be able to sit down and take the test when you have a chunk of time to do it. You're not going to be able to take the test and then leave and come back to the exam. So just make sure you have enough time to do it. I am planning on the test to be about 2 hours long, but maybe it will take you a little less, and I'll extend the time to have a little extra time just in case you need it. When you're taking the exam, you're going to want to be writing out the solutions, just like you're writing out solutions on your homework. Do this with like you're taking the exam and show your step-by-step process of how you got your answer. I'll go back onto, and then you're going to upload your work within 15 minutes of the posted time you finished the exam on my math lab. So I'm going to look at those times too. So the grade of the exam will be the points that you got from my math lab, but I'm also going to look at the questions that you got wrong. I'll look at your work, and if you had the right process, but the question, but you had a little bit of error in there, I'll give partial credit. Also, if you have the correct answer on my math lab, but you have no work shown, then I might not give you any credit or points on that. The other thing that you want to do with the exam is the last question on the exam, you're going to just pull out your phone or whatever device, and you're going to record yourself showing the work and explaining how you would do that problem. And then I'll give points on that. Everybody's last question should be a different last question. I'm going to have it so my math lab is scrambling everybody's questions, so the order is going to be different, plus the numbers are going to be different. So that's just going to, that's going to make it a little harder for me to grade because I don't have one key. But my math lab, I guess, does grade part of it itself. And then you're going to want to upload that video. Of you doing that last question, you also want to upload that. So you have 2 different assignments on Canvas that say test 2. One says the written work and one says the video. So any questions about the test? So you can use your calculator. I'm going to try to make it that you don't need a calculator. I was just writing my exam for Math 52, and unfortunately, you guys have that wonderful app, Photomath, and so it's kind of making me rewrite and how I'm going to think and how I'm going to write your exams, because I downloaded that app yesterday, and certain questions, I mean, bam, it shows you exactly what you want and what method of solving it. So I found ways around that, and I tested it on a question for calculus, and of course it knew exactly what to do using implicit differentiation and stuff. So I might have to work around that by asking questions a little differently. But I will know more about that tomorrow when I give you a lecture, which I can kind of maybe guide you of how things might be phrased differently and how you would go about solving it.
Yeah, the thing is about Photomath is that, I played around with that app a little bit, and honestly, I wouldn't solely rely on it because it's not going to guarantee to give you all the answers for that specific problem for calculus or even for trig or, etc. But,
yeah, so
most
it might
of the
not
time
be as good.
it's just not available, if that makes sense.
So I noticed, like, when I was making the 52 test, then I was starting to, take pictures of every certain question. Right. So I noticed like things they didn't like, things like use the distance formula. find the distance with these 2 points. And so I was able to actually work around things like being able to test how the students knowing to add or subtract radicals or squaring radicals by like doing the distance formula, or it didn't like to solve equations that weren't real numbers, or to simplify, or look at the student's work and find the error. So there's ways I can work around it. But just kind of be aware that they might be phrased differently than just saying, find the derivative of this.
Right.
Because a lot of what your stuff is on derivatives. Well, yeah.
And another question I like to ask is, how would that work if I want to do like my accommodations for?
So I have everybody's accommodations. And so I can go in and manually give students extra time if that's something that they get, or anything else that they might get.
Okay.
We would work that out.
Right. I understand.
Any other questions? Okay, so the other thing is, so we're gonna get into new material today. We'll review a little bit tomorrow, depending if you guys have questions and how much I can guide you and how much different it will be. And then Wednesday, I am gonna lecture at the normal time. You can come and watch the lecture, or I can just record it to nobody. But I am gonna do that just because we are a little bit behind and I need to catch up so that we get through all the material. And so if I can record on days that are exams, then that will be helpful.
Yeah, I realized that the other day that we are a little bit behind just due to the fact that the pandemic, just how it impacted the whole educational system and whatnot.
Yeah. So and we're looking at it, and I reviewed it over spring break. We're actually kind of in a good position because I had like a week scheduled for us and cushion for us to study for the final. And
Right.
so we have some cushion on that end. Okay, so we're getting into Rolle's theorem and the mean value theorem. So basically what the mean value theorem says is that if f is a continuous function on some interval a, b, so let's just draw some continuous function. So let's say that this is a and this is b. And it's differentiable on the open interval AB, then there must exist some value C in between this interval AB such that the derivative at C is equal to f of b minus f of a all over b minus a. Okay. If you have points, right? This is when x is b. Right here, this would be our f of b value. Here, when x is a, this is going to be my a value. So f of a is my y value. And actually my f of b, let's just move that. Oops. Sorry about that. Let's see. Okay. Okay, so if we can take some line and join, I'm going to try to draw this and it's probably not going to go so great. Well, it's better than I thought. That joins them, right? This right here is just the slope between those 2 points. So what this theorem is saying is we can find some value C. So there's some C that's going to be contained in here, such that the derivative at that point is going to have the same slope as between these 2 points. So let's looking at the tangent line. And so basically, if we took the equation, took the derivative here, the slope of the tangent line would be that. Well, that's not the same as the slope. And so if we keep on moving along and keep on making that tangent line, there's going to be some place in here by this theorem. So it looks like it's more like up in here. That's going to have the same slope. So maybe. So let's say that was our C value. There might be multiple places. So if I look at the tangent line here, it's here. But what about, so right here, it's like this. But here's another value of C that looks like that tangent line. That would give us the same slope. So in this case, my f prime of C sub 1 is the same slope as between those 2 points, which is the same as the slope of the tangent line at C sub 2. Okay, so that's what that theorem is saying kind of graphically. Verbally, it's basically saying instantaneous rate of change is equal to your average rate of change. So between 2 points, the average rate of change, you're going to also have the instantaneous rate of change the same. Or the tangent line is parallel to the secant line. So remember 2 points that were far apart and you join them, we called that the secant line. And the tangent line was just the instantaneous rate of change at that point. Some more thoughts. Mean value theorem guarantees that at some point on the closed interval AB, the tangent line will be parallel to the secant line for that interval. Since parallel lines have the same slope, there is always some place on the interval where a continuous function is changing at the exact same rate of change, changing on the average of the entire interval. Okay, so let's put this into action. So we want to figure out what is the value C, x equals C, such that the conclusion, our mean value theorem, will hold for f on the interval 1, 3, given that f of x is equal to x cubed minus 7x plus 6. So first of all, first thing that you want to do on all of these, so first make sure your conditions hold. And you can use the mean value theorem. So shorthand for mean value theorem is MVT. Okay, so in order to be able to use the mean value theorem, the function has to be continuous on that interval. We're looking at f of x. This is continuous everywhere. It's a polynomial. And then it has to be differentiable everywhere. So there can't be any jumps or, well, if it was not continuous. If it's continuous, it wouldn't have a jump. It can't have any sharp corners. And this doesn't have any sharp corners either. And so we're okay, and this condition holds true. So the next thing that you want to do is we want to look at what is the slope, or find the equation, or slope, sorry. of the secant line. The points on the interval. Endpoints. Okay, so our interval is on 1 to 3. And so we need to figure out what f of 1 is. And we need to figure out what f of 3 is. So if we go back in and we plug in 1 wherever we see a x in our function, we're going to cube 1 minus 7 times x. So times 1 plus 6. So if I reduce that, I get 1 minus 7 plus 6. So 1 minus 7 is negative 6. Negative 6 plus 6 is 0. So we have a point at 1, 0. So now if we go in and we plug in 3 wherever we see an x in our f of x, so we have 3 cubed minus 7 times x, so 3 plus 6. 3 cubed is 27 minus 21 plus 6. So that 27 plus 6 is 33. 33 minus 21. So that would give me 12. So my point on here would be 312. Okay, so we're trying to find the slope between those 2 points. So our change in our y value, so 12 minus 0, all over the change in my x value, so 3 minus 1. So this is equal to 12 over 2, or 6. Okay, so there must be some value of x between 1 and 3 where the slope of that function has to be equal to 6. So MVT says there exists an x equals c such that f prime of c is equal to 6. So we need to first figure out what our derivative is. And so let me just rewrite f of x here. So f of x was x cubed minus 7x plus 6. So we want to figure out what the derivative is. So derivative of x cubed is 3x squared. Derivative of negative 7x is minus 7. And the derivative of the constant is 0. So we're looking at trying to figure out what value sets our derivative equal to 6. So when is 3x squared minus 7 equal to 6? So if you add 7 to both sides of that equation, we would get 3x squared is equal to 6 plus 7, so that's 13. Divide both sides by 3, I get x squared equals 13 thirds. Take the square root of both sides, I get plus or minus the square root of 13 thirds. Okay, so it's telling me there's 2 places for the function f of x, what would give me a slope of 6. And so one other thing that you need to do on this is only choose the x values that fall in between A, B, the interval. So X contained in our case was between 1 and 3, right? And so I wouldn't use negative root 13 over 3 because that's outside of the interval. And so my solution is just going to be that X equals square root of 13 over 3. So I'm not sure if my math lab will take that or if it's going to want you to rationalize the denominator. If it rationalizes the denominator, multiply both by numerator and denominator by root 3, so we get square root of 39 over 3. And I just want to make sure that that should fall between 1 and 3. Can't see. So approximately 2.1, and 2.1 falls in that interval. Oops. So any questions? If you want, I can try to make it so you can see it more.
So you gotten from the X equals square root of 13 over 3.
Uh-huh.
And now, did you rationalize that? Is that what you did?
Yeah, so I multiply both the numerator and denominator by root 3.
Mm-hmm.
And so that would give me, square root of 9 on the denominator,
Okay. All right. I'm just curious.
which is 3. So actually, it would be kind of cool if I could, which I know I can. So we just looked at y equals x cubed. Oh, sorry, cubed. What was it, plus 7x? Plus 6?
It was minus 7x.
Minus 7x. And then we were looking in between 1 and 3. So 1, we found this was our point, and at 3, sorry. Darn it, I wanted it to leave it there. It's giving my intercepts. I guess it's not showing it as what I kind of want to show you. But basically, if we looked at this point, these points and this slope, we found where that same derivative is going to give us that same slope. Okay. Let me blow this up a little. Okay, so the next example says, given that f of x equals 5 minus 4 over x, find the values of c in the open interval 1, 4 such that the derivative is equal to that. Okay, so notice that if they gave us an interval where x was equal to 0, if 0 fell in that interval, we couldn't use the mean value theorem because this function is undefined when x equals 0. You have an asymptote. But because that's the only place it's undefined and it's defined between 1 and 4, we can use the mean value theorem. And so we want to first figure out what f of 4 minus f of 1 is. And so we need to look at what is f of 1. So plugging in 1 wherever you see an x, you get 5 minus 4 over 1. 5 minus 4 gives us 1. So we have a point at 1, 1. Actually, you can see it right here. F of 4 is 5 minus 4 over 4, which is 5 minus 1, which is 4. And so if we look at this, we have f of 4. What's going on? Okay, so we get f of 4 is 4 minus f of 1, which is 1, all over 4 minus 1. So we get 3 over 3, which is 1. So we need to find when is f prime of x equal to the slope between those two endpoints, which is 1. Okay, so f of x, let me rewrite it a little bit to take the derivative. So I don't want to use the quotient rule on 4 over x, so I'm going to rewrite it as 4x raised to the negative 1 power. So now we can take the derivative pretty easily. Derivative of a constant is 0. So then we get minus, bring down our power negative 1, multiply it to negative 4. So this actually gives me positive 4x, and subtract 1 from this power, I get negative 2. So we're looking at when is 4 over x squared equal to 1. So we could multiply both sides by x squared to clear our fraction. We get 4 is equal to x squared. Take the square root of both sides. Get plus or minus the square root of 4. Which is plus or minus 2. So again, you got to make sure that they fall inside our interval. And so our interval was between 1 and 4. So our value, which would give us that derivative of 1, is at 2. It's not too bad. So it's pretty much taking what we've done in the past, doing derivatives, looking at slopes like we did in the past with secant lines, and kind of putting it together. Let's see. So what values x on the interval 2, 3 does it, the MVT satisfy this equation? So that's pretty much what we just did. Let's skip this for now and come back if we have time. Okay, special notes. So y equals the absolute value of x on the interval 1, 1 fails at a point. The function is differentiable on the interior negative 1, 1, except for x equals 0. Therefore, the graph has no tangent line parallel to the chord AB. Okay. So basically, MVT doesn't hold here. sharp corner, and we know it's not differentiable at a sharp corner. Okay, so Rolle's theorem is almost identical to the mean value theorem. Basically, we're using the mean value theorem, and it gives us a little bit, narrows it in a little bit more. Okay, so Rolle's theorem. So let f be continuous on a closed interval AB and differentiable on an open interval AB. Okay, so those things, same things have to hold in order for us to use this theorem. If f of A equals f of B, so that's telling me the same y value I'm getting at my endpoints. So if I have the same y value at my endpoints, then there exists at least one number C in AB such that the derivative is equal to 0. Okay, well, let's look at that real quick. So let's say I choose, let's find 2 points that are the same y value. Actually, so if I chose 2 x values, let's say this is A, and that this is B. And it's telling me my x and y, or the y values are the same. So f of A equals f of B. Well, if you join the line of those 2 points, notice that it is a horizontal line. And so basically that's telling me there has to be some value, at least one value between A and B, such that the slope of my line is 0. So it's pretty much just the mean value theorem, but limited to the condition now that those 2 n values of our interval endpoints are equal to each other. So just reading what I had typed, verbally says if the conditions hold true, then there's at least one number between A and B so that the tangent line is horizontal. Or graphically says there is at least one point where the slope of the tangent line is 0 on the interval. Okay, so let's look at an example. And let me see if I have a harder example. No. Okay, so let's do this one and then I might pull them from the book if we have time. So first of all, determine whether Rolle's theorem can be applied. And if so, then we're going to find that value between negative and 2 such this holds. And so for Rolle's theorem to hold, 1, is it continuous on our interval AB? Well, if I look at my function f of x, it's a polynomial, so it is. Is it differentiable on my interval AB? Again, it's a polynomial, so I don't have any jumps or I don't have any sharp corners. So it is. And then we need to show is the n values of our n intervals is f of A equal to f of B. So I want to look at f of negative 2. And I want to know, is that the same thing as f of 2? Well, quickly, if I look up here and I look at it, the values I'm plugging in for x, they're all raised to an even power. And so if I plug in negative 2 and raise that to an even power, so I'm going to get the same result as plugging in positive 2 and raising that to an even power. So just by logic, I can tell you that, yes, this is going to work. But we could show it if you really wanted to. So negative 2 to the 4th minus 2 times negative 2 squared is equal to 2 to the 4th minus 2 squared. So that tells us that because we have our slope of the secant line, those are the same, is going to be 0. And so we have to have some slope between negative 2 and 2, some value of x that gives us the slope of 0 there. And so we got to figure out what the derivative is. So we want to find when is equal to 0. So our derivative of x to the 4th is x cubed minus the derivative of 2x squared gives us 4x. And when is that? 0. Okay, so looking at this, it's not a linear equation. I notice I can factor this. We can pull out a 4x from both terms. If I do that, we're left with an x squared for the first term minus 1 for the second term is equal to 0. Looking at it further, I notice x squared minus 1 is a difference of squares, and we can factor that further. And so that's x minus 1 times x plus 1 equals 0. So finding the values, what set this equal to 0? When is 4x equal to 0? Well, that's when x is 0. X minus 1 is equal to 0 when x is 1. And x plus 1 is 0 when x is equal to negative 1. And so if we looked at our interval though, our interval is between negative 2 and 2, right? And so we want to choose all the values that fall in between there. And all those values are contained in there. So Rolle's theorem, basically, it's telling us that we're going to have some max and mins, right? Because we are trying to find, and that's what we were doing in 4.1, we were trying to find when do we have absolute max or absolute mins, local max, local min. Another terminology for saying that is find the local maxima or absolute maxima, sorry, extrema is what I wanted to say. Okay, I don't have my textbook in front of me, so I'm not going to pull one out. So let me go back. Let's do one more problem. Let's just do the one that's here. Find two intercepts of f of x equals x squared minus 3x plus 2, and then show f prime of x equals 0 at some point of these two x intercepts. So basically, we're trying to find where this is crossing our x-axis. And then we know this is, we can tell what the shape of this is. We know this is a parabola facing up. If we can find those values where it's crossing the x-axis, we know that there's some value in between here such that our slope is going to be 0. And so now I need to figure out when is my equation f of x equal to 0. And so looking at x squared minus 3x plus 2, I notice that factors. So there's two numbers that multiply to positive 2 and add to negative 3. So that would be negative 2 and negative 1. So f of x is equal to 0 at x equals 2 and at x equals 1. So there should be some value between 1, 2. Such that f prime of x is equal to 0. So now we need to look at the derivative of our function. So derivative of x squared gives us 2x minus derivative of 3x is 3, and the derivative of our constant is 0. And so we're looking at when is 2x minus 3 equal to 0? Add 3. So when is 2x equal to 3 divided by 2? My screen is starting to freeze. So this is when x is equal to 3/2. So we found the x value, and it is in between 1 and 2 such that our derivative of the function was 0. So any questions on that? Let me pause the